So how much design time can these advanced PCB design technologies save?
Well, from research and from what we've heard from our customers, we're hearing anywhere from 50 to 70%.
You asked, and we're answering. Whether you attended one of our PADS Professional PCB Design Accelerated webinars, events live, or watched the recording on demand, some great questions were asked. So, let's get the answers. Hi there, I'm John McMillan, and welcome back to another edition of this special series of PCB Tech Talks, the After the Webinar podcast series. In this special podcast series, I'm joined by webinar presenters, and we answer and discuss the questions submitted by attendees. As always, be sure to subscribe to this podcast and let us know the topics you'd like to discuss and if you'd like to be our guest right here on PCB Tech Talk. Today, I'm joined once again by the webinar demo presenter, Brent Klingfirth. Before we get started, let's do a fun quick lightning round of questions for you. So what's the most nets you've had in a PCB design? Do you remember?
For me, probably about 10,000.
Yeah, that's good. And what's the most layers you've done for a PCB design?
About, I think, 14 or 16 layer board.
Do you remember how many components were on the biggest board?
Components, I'd probably have to guess around 1,000 or so.
Okay, so have you worked on any product that people may recognize or may actually own?
Well, I can think of right off the top of my head is I did some stuff for home electric meters that did a mesh network and then reported back to a base station so that people didn't have to go around with little scanners and check your house for how much electricity you've used, like they had to do back in the past.
Yeah, they're kind of doing that with water meters now. They're kind of putting in these Bluetooth or devices so they don't have to come and check your meter manually. So that's cool.
Yeah, exactly. It's kind of like where we're headed in the age of IoT. It's just it happened, like 15 years ago.
Okay, cool. Well, welcome back, Brent. And as folks know, we're here to address the After the Webinar series questions from the Advanced PCBs Design Technologies webinar we had last week. I think it was a great event. What do you think?
Yeah, thanks, John. It was a really good event, actually. We had close to 1,000 people register, and a good portion of those attended. A lot of good questions came out of it, so we've got a lot of questions to cover here today.
Yeah, we sure do. So why don't you just jump right in? And so we'll be addressing not just the questions we addressed during the webinar, but also the other ones we didn't get to address during the time that we had allotted for that. So you'll be hearing the questions from the European, North American sessions, as well as the ones we didn't get to in both sessions. So I'll let you kick this off, Brent.
All right. So first question here. Does everything you showed today come in PADS Professional? Pretty much everything that I showed during the webinar does come in the base package of the tool, except for one item, and that is during the demonstration you saw where I grabbed a bunch of nets and I tuned them all at once. That is an option for the tool right now, but it's definitely worth something looking at. If you've got a lot of length matching to do on a design, like you've got a big DDR section or a bunch of, high-speed differential pairs, and you don't want to sit there and tune each individual one, even though the manual tuning function is pretty fast, you still have to touch each one, obviously, when you do that. The multi-trace tuning feature just allows you to get things done faster, like we mentioned earlier, 50 to 70% faster. So that's just something to look at.
Yeah, that's definitely a huge time saver. I'll take one next. Do you have to configure the setup for things like routing and teardrops and fanouts for every design? And that's really a great question, and it's a common practice. I don't know about you, Brent, but I have always saved database templates. So for example, I have 4, 6, and 8, 10 layer templates for designs that I do in those different areas, and I always start with those. So for businesses that use the same form factor or the board envelope, like you do different blades for servers and routers, and even starter templates for different shaped boards, saving and reusing design templates that have a lot of these things that you already filled in when you bring up a design can save you lots of time. So that's a great question.
Yep, good one. Another one here this one's kind of not related to PADS Professional, but that's still a good question. Are advanced rules and constraints available in PADS Logic? Yes, they are for those that are using the PADS Standard Plus tools. You can enter advanced rules to some extent at the schematic level. You can create classes, which I covered in pads professional anyway, and why they're important actually. But you can't do things like pin pair rules, but you can create conditional based rules for doing layer based impedance control. You can do differential pair setups and such.
Okay.
Let's see a second one here. What are tools for schematic correction on the fly, like pin swapping or line correction? Probably in PCB editor with synchronization, these changes back to the schematic. So in Paths Professional, you can go in and do pin swapping on your parts. You just need to make sure your library parts are built appropriately for that. That's a big one that a lot of people always forget about when they're making their library items, is you need to define your pin pair or pin swapping functionality at the library level. And then the layout tool allows you to go in and do pin swapping, and then you can back annotate that onto the schematic.
Cool. I have a question here. What if I need to move one of the physical interface components that came in on the MCAD baseline file so I can route the PCB optimally? And that's a really great question. So MCAD collaboration is designed to facilitate just that. So for example, if you're shifting apart, like one of the USB connectors that you saw in the design, 100 mils would make routing signals a lot easier. You can move it, propose it back to MCAD in real time. It's kind of a negotiation, and it creates a win-win essentially for both MCAD and ECAD. ECAD can design the most electrically optimal PCB layout, and MCAD doesn't have to worry about the PCB not fitting in the enclosure when it comes time for assembly by discovering a connector has been moved and they didn't know about it. So real-time MCAD collaboration facilitates just that.
Yeah, and to go along with that one, we actually did a webinar completely on that topic earlier this year. If you go to pads.com and go to resources, you can see that webinar and watch that at your leisure. But it will definitely cover all those questions related to why MCAD collaboration is so important today. Again, in reducing your design cycles, so you're not sitting there going back and forth verbally and in design meetings trying to collaborate with your mechanical engineer. Another question here: can inside corners of planes be converted into curves for current density reduction? Yeah, I actually showed that during the webinar. There's a section where I start going into plane automation, where I show you can select a shape and automatically turn all the square corners that I drew into arcs. Now, you don't have to do all the corners. You can choose one corner and do it, or you can just select the entire shape and do everything. So yes, that's definitely a capability, and I highly recommend doing it on a lot of designs actually.
Yeah, and just to reiterate, when you mentioned the past webinar we had on collaboration, we also have, to get more in depth on advanced routing and electrical DRCs, there's also on-demand webinars for both of those.
Another good question here is, are these tools also available in Pad Standard Plus? A lot of the things I mentioned can be done in Pad Standard, but there are certain things that are Pads Professional specific. The sketch routing technology that I showed, which to me is probably one of the biggest time savers in what we're talking about here, is not available in Pad Standard. You just have to use auto routing technology, which is still a big benefit and something I very much advocate when designing a board, is that you take advantage of auto routing technology. The days of point and click routing an entire design are over. It just takes way too long. And our auto routing technology today is very impressive and works extremely well. If anything, at least do interactive routing again, which are in both tools. I showed that in Paths Professional as well. I actually did a little timed session where I showed interactive routing of a section versus using sketch routing, and the sketch routing section was 5 times faster and did the identical job as me routing those traces by hand using interactive push and shove. So that's where using this, again, auto routing technology really comes into play. And to go along with what John mentioned, we did another webinar specifically on routing automation. So I cover many topics more in depth using auto router technology to your advantage.
I just got a report back from our Realize Live conference up in Detroit, and one of the presenters was talking about how people are kind of giving up a competitive advantage by not using advanced technologies like Sketch Router. And what are your thoughts on that? I've often wondered why people just don't jump on these new productivity enhancement things like sketch routing and group placement. What are your thoughts on that?
Yeah, over my years of being an application engineer and going out and visiting customers, that was probably the number one thing I showed customers, believe it or not, is a lot of people just get used to designing in a certain way and they don't change. They're so busy in their jobs, they don't have a lot of time to go out and see all the new technology that's available, even in the tool flow they own, let alone other ones out there. And that's really why we're doing these webinars is, again, to really let people know that, there's more in the tools today than what was there 15 years ago. So I think it's just a mindset thing that people have a hard time adjusting to new things. But once they do, everyone that I know has started using, just even interactive routing where I can just guide a trace across the board and let it push and shove things. Would never go back to point and click routing technology. It's antiquated,
Yeah,
and
I
our tools today do such a good job.
I agree, and that was one of his key points. Is he worked in a big company where there actually other design groups where his group was more productive than the others, just because they were early adopters and continued to utilize these advanced technologies when they hit the road. So it creates kind of a buzz in the company when you see one group is really outperforming the others and using the same tool, but taking advantage of those things. So I'll jump into another one. How do you know when the tune routes are correct? That's a really good question. You may have noticed when Brent was routing he selected a differential pair, tune box, that there was a yellow indicator bar to the right of his cursor. So as he added serpentine tuning to the traces, lengthening them, it turned green when the lengths were within the correct min-max range. And if he went out of the range, of course, it would turn back yellow again. So he could always just continually moving his mouse around until he dialed it right in.
And to go along with that question, we had someone ask, how does high-speed routing handle phase matching for differential pairs? So in constraint editor system for PAS Professional, you can set phase matching values so that when you tune a set of differential pairs, or if you have that multi-trace tuning option, it can automatically phase match the differential pairs for you, so that you don't have to, worry about doing that manually. But that is definitely a rule that can be set in the tool, and again, using automation, have it do it for you. Let's see, what are the advantages and disadvantages of using the serpentine routing? For those that haven't done any high-speed routing, and even those that have, serpentine routing is just basically a mechanism of adding length matching to traces. There's a lot of different ways you can do it. You can draw what a lot of people call trombones because they look like a trombone horn, where you just have traces that go up, back down again, up, back down again, right next to each other. They're kind of more compact. Or there's a method called meandering where you can either do it manually or the tool can actually just kind of meander the trace all over the place in a certain area. Anyway, it's not going to go all over the board, but that adds length to the trace. The goal again being that we're matching the length of all these traces to minimize time disparities from when a signal goes from one chip to another within a group. The biggest example for that is obviously DDR memory. All the signals from a data bus have to go from point A to point B at the same time, or you don't get the right data transfer speeds that we're looking for today. Everything has to be faster today, whereas humans, we're always looking for everything to be faster. I know when my internet's slow, I get frustrated. And when it's fast, I'm happy.
Me too. I got another
Another,
question here.
all right.
Can you predefine plane keep out or include plane areas for components themselves? So yeah, you can not only have a predefined plane areas for components, you can also create trace rules for component boundaries. That is, when traces cross the component boundary, that it will neck down to a smaller trace width, say from 6 to 4 mils to facilitate optimal routing and breakouts. I don't think there was any in your presentation, Brent, but that's a pretty common thing to do when you're breaking out a fine pitch BGA, for example.
Yeah, it wasn't very obvious, and I guess I didn't really point it out, but they're both the BGAs in that design that I use during the demonstration have rule areas on them, and you can see it in there when the traces go in and out of that rule area where it necks the trace down or up. whether you're coming in or out. So it is there in the design. I just really didn't point it out. But like I said, our advanced routing automation webinar, I do explicitly call that out. So if you want to get a little more detail on that, that's pointed out in that webinar. Let's see. I have pads. I do not have Expedition. Any chance I can get access to webinars that show how to do PCB design using pads? There are actually quite a few webinars archived on pads.com that are related to pads in general. But a lot of the techniques that I show in some of these webinars, like the MCAD collaboration, even some of the things I show in advanced routing and some of the things I've showed in advanced PCB, that technology is available in pads as well, in standard plus anyway. So it can still be advantageous to watch those. I mean, one of the big enhancements added in Pad Standard Plus several releases ago was dynamic planes. So having the ability for the planes to automatically fill, so you don't have to do a flood process like most tools do today, which is actually kind of a nice enhancement. It's something that I didn't think was going to be that big of a deal. But again, once you start playing with something, you go, oh, wow, this is actually really kind of nice. I'm going to start using this more than going back to what I was doing. That's a big thing of us showing technology in these webinars, is to get you to try it, because you may not know it's there. You're so busy doing your job. So can you share layout reuse files with other designers? So in the demonstration, again, I show some design reuse technology with a USB circuit within the same design. The reuse files that you create within Pads Professional can be saved out to individual files and then used between any design. So if you place those files, like you could have a reuse library sitting out on the network, and then any designer that's, obviously using Pads Professional could go out and have access to that information. And again, for those using Pads Standard Plus out there, you can do the same thing. You can create a reuse file, save it out to a file, and then use it with other designers. I just think there's definitely some technology advantages of doing design reuse inside Professional, like having it remember reference designator, placement location. You can flip a reuse from top to bottom of the board, which is actually a really nice function. Where can I find out more information on collaboration that you showed during the component placement? So kind of talked about that already. We did a webinar dedicated to MCAD collaboration that you can go look at on pads.com. If you create component groups in layout, can you sync them to the schematic? So obviously the real advantage here is if the electrical engineer can create those component groups for us, saving us time. And if you do any hierarchical design with Pads Designer, those groups are automatically made for you. But in the case of where the electrical designer didn't do it, yes, we can create any types of groups that we want in the layout, and then using the synchronization, we can push all of that back onto the schematic. So if we reuse this design in the future, all of that will actually be created for us. Instead of using built-in schematic viewer to assist with placement, can I actually use the schematic tool? So again, during the demonstration, I showed using an embedded schematic tool to cross-probe with the layout and the component explorer to assist with placement. But you do still have the capability to have the schematic up on one screen, the layout on another screen, and cross-probe with that schematic to assist with component placement. So yes, that capability is still there. Let's see, are constraints the same between PCB and schematic? So yes, that is actually one of the big advantages of Pads Professional or some other tools in the industry. Some tools actually limit the design rules that you can set at a schematic stage, making the PCB designer do more of the constraint entry. Not with Pads Professional. All the constraints that can be entered at a PCB level can absolutely be entered at the schematic level, because you use the same rule environment for doing that. So the constraint editor system is the exact same from the schematic as it is from the PCB. So if you're a layout designer out there not doing the electrical design, you can push back some of your design rule entry on the electrical engineer and prevent things like having to send emails or create Word document or documents I should say, that contain design rule requirements. Now the electrical engineer can absolutely define everything he needs to at the schematic level, again, reducing wasted time. So a couple more here. Can you place vias and copper in a footprint? This is actually something that a lot of people don't end up doing that can be nice and a big time saver is with Paths Professional. Again, it's using Expedition technology. Yes, you absolutely can do this. This is why in Paths Pro, footprints are called cells because it adapts some of the name from the IC industry, meaning a cell is basically a hierarchical piece of your design almost. So in the footprint, I can create not only what the footprint is, but I can add traces, I can add vias, I can add other structures into that footprint. One of the most common things this would be used for is components that have thermal pads in the center. A lot of times you have to place those vias, after the fact, where now if you have one of these parts, you can place actual vias in the footprint so that when you bring it into the design, that's already been done. And then on top of that, you can even modify the footprint on the fly in the design if needed. And the last one, can you adjust spacing rules from the constraint panel in Pro? So if you missed the webinar, I showed a secondary way of adjusting some design rules related to constraints. We call constraints, we use that name in Pro as a way of entering all of your high-speed or non-clearance-based design rules, things like differential pairs, length requirements, topology, items like that. But then clearance rules are just that. They're called clearance rules. In the webinar, I created some differential pairs on the fly that I had forgotten about earlier while I was going through the constraint editor system, and I was able to make those differential pairs on the fly right inside of the layout editor, making it much easier for me to deal with. Plus, I could adjust some basic settings on that, like if I wanted to set a length requirement and I wanted to adjust it real quick, using that panel allows me to do that. And that is both available in the schematic editor and the PCB editor as well.
Awesome.
I think that's all we got, John.
Yeah, I think that wraps it up. And thank you, Brent, and another great webinar, by the way. Great job.
Yep. Thank you, John. And thank you, everyone, for attending. And look for more great webinars. What's our webinar next month, John?
Signal integrity analysis. And I'll be adding some into the show notes. I'll be giving a link to how people can register for that. Thanks, Brent. And thank you for joining me for this special After the Webinar Series podcast. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussed, be sure to check out the show notes. There you'll also find additional information related to this podcast along with my email address, so feel free to send me your comments and questions or any topics you'd like to hear me talk about, or if you'd like to be my guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, iHeartRadio, Stitcher, or your favorite podcast app, and be sure to catch the next episode of PCB Tech Talk.